Good morning, everybody, and welcome to today's ArcServe webinar. My name is Charlie Smith, and I'm going to be talking to you today about 5 ways to win with Dedupe. It's interesting, before we kind of get stuck into the agenda and the topic, Dedupe has kind of been on the scene for quite a long time now, actually. You know, backup technology started to introduce Dedupe technology probably in the last 5 or 6 years, and there's different technologies available ranging from hardware to software, etc. But it's interesting that it is a bit of a minefield for customers because there's so many different types of Dedupe. There's vendors claiming all sorts of impressive ratios about how effective their Dedupe technologies are. And if I was a customer, I would be confused, and I think vendors have to take some blame and responsibility for muddying the water, all trying to put the best spin on their technology. But all Dedupe is not the same, and that's a key point that you have to remember. Dedupe is developed by the company who you're purchasing the technology from, so one Dedupe technology is not the same as another Dedupe technology. So what I'm going to do is I'll go through the agenda. I'm going to explain a little bit about how data deduplication works and the workflow behind it. I'm also going to look at different types of Dedupe, comparing, for example, inline versus post-process Dedupe, because there's a fundamental difference in where you actually do the Dedupe and at what stage of the backup process, if it is backup technology you're looking at. We're also going to take a look at compression, because most backup solutions don't just Dedupe, they also compress data to increase the overall data reduction rates. We're then going to look at how Dedupe works with backup technology in general, and also explain the different types of how Dedupe technology can be implemented to complement your backups. And also, I suppose, really getting to the crunch of the presentation is looking at how you can really win, and 5 key points to take into account when you're looking at Dedupe technology. We're also going to go through some ArcServe customer, I suppose, success stories and customers that have implemented our technology to show you some of the impressive Dedupe ratios they're getting. So some of this information isn't just us saying how wonderful we are. We've actually got customers, a lot of customers, telling us how good the Dedupe is, and we'll share some of that information with you. And at the end, we have a Q&A time. On the webinar software that you've connected into today, there is a questions panel, so if you want to raise a question, I am happy to answer questions offline. Unfortunately, we can't ask questions as we're presenting because it just breaks up the flow of the presentation, but we are happy to take questions at the end, and using the question panel is the easiest way to achieve that. So what I'm going to do now is I'm going to explain a little bit about how our Dedupe or Dedupe works in general, because as I've already said, there is a lot of different ways Dedupe can be implemented, but the concepts are the same for most Dedupe vendors. Now, our Dedupe technology is developed by a very, very clever guy in Shanghai. He works in our development team. This guy's got a PhD. He's a really clever guy, and he has some really in-depth slide decks talking about how our Dedupe works. Some of the slides are so technical, even I can't keep up with a lot of the information in them. But this slide kind of resonates with me because it kind of explains the flow in a logical way. So the first thing is you've got data coming in, okay? And the data is, you know, for all intents and purposes, is either the production data you're writing to disk, or it could be backup data being sent to your backup media server to be stored on disk. So the physical data comes in, and now what we do and what a lot of other vendors do is we break the data up into what we call chunks or blocks. And the reason why we do that is to make the Dedupe more effective. You can, for example, Dedupe at a whole file level if you wanted to, but the thing is with that approach is that if someone makes a change to, for example, an Excel spreadsheet or a Word document, and it could be that they just opened the document and closed it, and the properties of that file has just changed. You know, the last access or the last modified date and timestamp has changed. Now, if you were deduping at a file level, that would indicate there's a new version of that file by just opening and closing the file, because some of the properties have changed. And what that would mean is that we wouldn't dedupe that file, because we would treat it as a new file because the properties are different. So doing file level dedupe isn't very, very efficient, because we would simply, most of the data would be ignored, because if some property of the files that are coming in have changed, we would treat it as a new file. So by breaking the file up into blocks means that we can analyze each block, and only if one block or one block associated with a file has changed, we will just back up or reference that block and commit that to disk. So there are trade-offs here. The smaller the block size, the more efficient the dedupe is, because the chances are only one element of a file may have changed, and we would capture that in one of those small blocks. So having block sizes like 4K, 8K, for example, gives you very good dedupe ratios, because you're splitting the data up into very small pieces, and only the pieces that have actually changed in those small blocks will actually be referenced and backed up or deduplicated. Now, if you have larger block sizes, the dedupe is less efficient in the sense that it will back up more data, and less of it will be deduped. So that's just something, and we can discuss block size further down the presentation. Now, when you write a block, we have to give the block a signature, which is what we call the hash key. And the hash key is basically like a reference to that block and what has changed or what has not changed, depending on what's going on. So the hash key is really the signature of the block, and that goes into what we call the hash database. Now, the hash database can be a relational database for some vendors. It can also be a flat file database, which it is in ArcServe's case. Now, what happens is with these keys, if I have multiple blocks coming in, and those blocks are already recognized as data that's already been committed to disk, we will basically say, okay, this key already exists, and it already points to a block in the backup repository, and therefore we don't really need to back up the data again, because the block already exists. So what we do is we create an index pointing to that key, which is basically matching up to that latest recovery point for that machine coming in. So we have indexes pointing to the keys. The keys refer to the signature of the blocks, and the blocks determine what actual bits of the file or files that we're backing up are changing. So the hash database can grow in size. The more efficient your dedupe is, you tend to have a larger hash database, because there's more keys being referenced. The less changes that are made, i.e. you're not deduping as much, the hash database tends to stay smaller. So this is the kind of process, and this is all happening kind of in microseconds. You know, this is all happening real time, or it can happen post dedupe, and we'll talk about that a bit next. So I hope you understand the flow of dedupe. You've got data coming in, it gets broken into blocks, each block's analyzed, and only the relevant block that has changed will be committed into the database. If it's a new block or a changed block, if it's a block that already exists, it just gets referenced. Each block gets a hash key created, even if it's the same block or a new block, and then the hash key is held in the database. And each of those hash keys is indexed, so it can be looked up easily, especially when we come to restore data. We need the indexes to point to the hash keys, which are mapping all the data together, that we can then extract and recover from the disk storage. So the dedupe layer is really important, and really this is what I was saying to you before. How effective this piece of the puzzle has been developed really determines how effective your dedupe technology is overall. The technology we use in ArcServe is very, very good. It's been very well developed. It's been very well architected and thought out. And we've proven now beyond any reasonable doubt. We've had dedupe in UDP since 2014, and we have a very large customer base now, and the technology works really well. So this is kind of how the dedupe technology all hangs together. Now, there are different types of dedupe as well. Not so much the process of breaking the blocks up and creating the hash keys and the indexes most dedupe technologies use a similar process to us. But in terms of where you do the dedupe is really also equally important. Now, we've talked about some of the properties here, fixed vs variable block. Fixed block tends to give you the best dedupe ratios because we just break the data up in a very logical sequence. It's, you know, if you've got a 4K block size set in your data store, we just break all the files up into 4K blocks and analyze those 4K blocks, and only the changes in one 4K block will be affected. We provide a hash key, we put it in the hash database, we write the block to disk if it's new or changed. If it's an existing block, we just point the key to an existing block and we index it. So having variable block is another way you can do dedupe, and that tends to work well with file types that are well understood. So having, for example, variable block dedupe for things like Office documents where the data structures are very well understood can be quite effective because you know, for example, you know, we know where the property indexes for a file are kept, so we can make a variable block that will back up the data in an efficient way and recognize just the changes made in the properties of a file, for example. So there are different ways to do it. We prefer to do fixed block because it's more methodical and it's easier to process the data. And there are various block sizes that you can set in your backup software. What you tend to find is the smaller the block, the more efficient the dedupe is, but then there is a slight trade-off that the recovery time will be slightly extended because there's more indexes and hash keys to be looked up when you're retrieving data, which is going to put a slight overhead on the recovery time. The larger the block size, the dedupe is slightly less efficient, but then it will give you much faster recovery time because there's less work having to be done to piece the data together. Now, in terms of performance trade-offs, you know, a few years ago, when dedupe really started to become popular in backup technology, post-dedupe was really the most popular method of dedupe because with post-dedupe, there was less computing power required because it was almost a post-backup process. You basically write all your backup data to a big disk area, and then after the backup completes, a post-process kicks in, and it will then analyze all the data and start to deduplicate it. The benefit of post-dedupe is the fact that you don't need as much computing power to do it real time, but the downside of post-dedupe is that you need a large amount of disk. You need to have enough disk to hold the full size of the backup undeduplicated before you and then start to do the dedupe process. And this really becomes important when you look at how a lot of backup vendors that are on the market today do their dedupe. A lot of technologies use what we call post-dedupe. The downside of that is that it's less efficient because you need to have a lot more storage available to do the dedupe. The other big trend that's happened over the last 4 or 5 years is that CPU, memory, and disk has become much, much cheaper and more affordable. And every time you buy a server now, it's probably 10 times more powerful than the server that you bought 3 or 4 years ago because processing technology has moved on. And also the cost for the random access memory is really cheap now. And even SSD storage, which we do recommend for dedupe disks, is becoming very, very affordable now. Even 2 or 3 years ago, SSDs were very expensive, especially when you look at things like SAS SSDs and high-end SSD storage. But there's been a massive trend in the market now that SSDs are coming down in price. CPU and RAM is much cheaper than ever before on new servers. So the dawn of inline dedupe has really become to the forefront now because the reason why people did post-dedupe 4 or 5 years ago are kind of being blown out of the water to a certain degree because the technology's moved on. And the benefit of doing inline dedupe is that you don't need to have this big storage pool at the back end to retain the full backup size before it's deduped. We can do it on the fly and make it very efficient. So you're only needing the storage to hold the deduplicated data size on disk. as we're reading the data in, and there's no sort of staging or caching area that we need to dump the full size of the backup as you do with post-dedupe. So we believe that inline is more efficient than post-process because technology is caught up now to do the inline process much more, how can I put it, much more slicker than ever before because of the computing power that we now have available, and significantly you can use a lot less storage. And that has a big commercial factor in when you're looking at a solution. You will notice that, for example, there's lots of appliance vendors on the market today that will tell you that if you want to back up 10 terabytes of data, you need to buy an appliance that has 20 terabytes of disk in it. And the reason why they tell you that is because their appliances use post-dedupe, not inline. So they need a lot more storage available to land the initial backup on disk and then crunch it down afterwards. So eventually you will get the benefit of dedupe once the post-process has kicked in. But initially you don't get the benefit of it because you have to land the full size of the backup to the disk. So there are performance trade-offs, but I think technology has moved on now that has become less of an issue. We believe that inline is more efficient for the reasons that I've stated. Also, compression. Now, compression is not data deduplication. So when people talk about compression rates, when they're referring to dedupe, it's just a general terminology of data reduction rates. But having said that, compression does complement dedupe really well, because with compression, you will typically get probably an extra anything from 10 to 20% data reduction on top of your data deduplication rates. So when you combine the two technologies together, you will find that it works really well. You sometimes get data that doesn't actually dedupe that well, but it will compress well. And you also get data that doesn't really compress well, but it dedupes really well. So using both technologies together is really effective. Now, compression works on the basis that when it analyzes a file that it's going to compress, it works out where the kind of white spaces are, where there are big blocks of fields of kind of null data that it can reduce out of a file, and it replaces these big white spaces with a smaller block, but it obviously maps that big white space to the smaller block. So when you extract the file, it will basically put the file back together exactly the way it was before it was compressed. So there are basically two types, what we call lossy and lossless. Lossy compression reduces bits by identifying unnecessary information and removing it, which is the way I was just describing it before. Typically used in image compression, bitmaps, JPEGs, large CAD files compress very well as well. Lossless data compression exploit statistical redundancy to represent data with fewer bits without losing information. For example, an image may have areas of color that do not change over several pixels instead of coding. So the data may be encoded in a different way using red pixels. So there are different compression technologies available. But the key thing to take from this slide is that compression is not dedupe. Compression complements dedupe because you can basically attack data from two angles. You can compress and dedupe. So one thing to look for is any dedupe technology, you should be compressing the data as well. And if you're speaking to someone or a vendor that says we dedupe but we don't compress, I would be concerned about that, because really to get the most effective data reduction overall, you should be doing both things. Now, what we're going to talk about now is why dedupe for backups, and how does dedupe affect backups in general. And now, if we take this slide here, it's a very simple slide. You've got 20 terabytes of data, 2% growth rate, and you've got a 3% incremental change rate going on. So the first time you back up the data, week 1, you back up 20 terabytes. And then week 2, you're backing up the same data again, which is the 20 terabytes, plus the changes, which is the 2% growth and the 3% change, which adds another terabyte of, on top. So the second backup, you're backing up 41 terabytes because you've got 2 full backups plus the changes. And then week 3, it keeps on multiplying up. You've got 60 terabytes of the base data plus all the changes, which adds up to 63 terabytes, and so on. And the challenge is that going back 5 or 6 years ago, when things like Microsoft DPM came on the market and other image block level backup solutions, the technology was great at the front end, but the challenge was these products just ate storage like there was no tomorrow. And the problem a lot of customers had is that they have so much data, it wasn't sustainable just to back up data, even just using compression on its own. The data would just, the backup sets would be so large. And that's why a lot of customers just continue to use tape backup, because tape still offered a very cost-effective way to write lots and lots of data to a cheaper storage medium that could be shipped off-site. So the day of disk-based backups really didn't kick off until data deduplication really hit the market. So that's kind of how it works in a kind of non-deduped, disk-based backup. Now, the other thing that happened over the last 4 or 5 years is that, there are a lot of purpose-built backup appliances on the market, PBBAs, as the vendors call them, or the analysts call them. Now, statistically, there is about 64% of companies in the world today use PBBAs somewhere in their environment, and it could be for different reasons. Some people use backup appliances because they're using a legacy backup product that doesn't have dedupe technology built into it. So by writing the data to an appliance, it means that you can complement your backup technology that doesn't support dedupe natively and deduplicate the backup data. Now, in one sense, that's good. In the other sense, it's not so good, because I'll explain why. Dedupe appliances tend to be very, very expensive, and that's the first point, the cost associated. There are a number of products on the market. You've got Data Domain, you've got Exagrid, you've got Quantum. There's lots of different dedupe appliances. HP sell them, and Dell, other major IT companies as well. Now, the first sort of notable trend is that a lot of these appliances are very expensive. If you look at things like Data Domain, you're talking a 6-figure sum for a sizable dedupe appliance. And if you've got a limited budget for your backup project in your IT department, the last thing you want to be doing is spending 3/4 of that budget, if not more, on the actual backup hardware, because it's just going to kill the project stone dead. The other thing is that we'll talk about this a bit more, and these provide what we call either inline or post-level dedupe. And going back to what we were talking about before, some of the cleverer appliances use inline dedupe, like products like Data Domain. Some of them use post-dedupe, like Exagrid and others. And the problem with it is that the market's kind of caught up now. That gone are the days where you need to buy a purpose-built appliance just purely for dedupe, because you can get it in the software layer. But we do still see these a lot. When I'm speaking to customers, it's often, the customer bought Data Domain appliances 4 years ago. They were using Net Backup or some other legacy backup solution, and they want to leverage that investment because they paid a lot of money for them. And I understand that kind of the train of thought as well. But if you're a new customer looking to put in a new solution, I would really be wary about going down the purpose-built backup appliance route, because there really is absolutely no need to do that today. Now, if you look at how a backup appliance works, like a Data Domain or an Exagrid, you basically have 3 levels. You've got what you're protecting at the front end. You then have your backup service, because with a purpose-built appliance, you still need to have a server that actually takes the backups and connects to the client agents and backs up your SQL and your Exchange and your systems, your physical and your virtual. Now, the problem with backup appliances, you only get the benefit of the dedupe at the last hop of the process, as it were. So what you're protecting is the full size of the data. So if I've got 100 terabytes of data, and I take a full backup, 100 terabytes of data gets sent across the network, okay? And then the backup server has to process 100 terabytes of data. And it's not until you're actually writing the data to the disk, which is managed by the purpose-built appliance, that you actually get the data reduction. So it's all happening at the back end. The downside is that it's still going to take the same amount of time to back up. It's still going to take the same amount of time to process. And it's only the data reduction at the very last stage. And that could be done inline or post-process, as we discussed previously. Now, if you kind of look at how the backup market is moving now and how it's changing, you'll notice in this slide that the last piece isn't a backup appliance, it's just general storage. And what we say to customers now is that, you know, disk is relatively cheap now. You know, you can go out and buy a nearline SAS RAID 6 or RAID 5 direct attached storage units to connect into your server, either via SAS or fiber, at a relatively low cost. And even if you look at NAS storage, the costs are even cheaper. So general storage is attractive in the sense that, you know, if you buy a HP StoreOnce device and it's got 50 terabytes of storage on it, the cost of that versus a HP direct attached storage unit with the same amount of storage, and the only difference is this little bit of dedupe technology sitting on the top of the appliance. You're probably talking another £50,000, if not more, that you're paying just for that dedupe technology. So the actual hardware that the dedupe appliances run on are quite low cost, and you're paying a lot of money for that dedupe layer sitting on top of that. Now, in this example, with source-side dedupe, you've got the full size of the data obviously sitting on the production servers being backed up. Now, with source-side dedupe, you get the benefit that the data's been reduced as it's written to the backup server. So you can see there that the backup server has a reduced amount of data because the backup software is now doing the dedupe. It has the intelligence and it's processing the data. So the amount of data then written to the storage is also in a dedupe format. But you'll notice that in this approach that the backup server is doing the work and the calculations and not the backup target, which is now the general storage. Now, the benefit of this approach is that you're getting a quicker data reduction to begin with, because we're reducing the amount of data sent over the network, because we're calculating what's unique at source. So that's going to give you faster backup times. And also, you're saving a lot of money on the hardware, as we said, because we can now use general storage and put the intelligence in the backup software. Now, you can really kind of go to the next level, which is what we call global source-side dedupe. So instead of just looking at each server we're backing up individually and calculating what's changed and what's unique and making those changes, with global source-side dedupe, it means if I'm backing up 50 servers and they're all running Windows 2012 R2, or they're running 2008 R2, or they're running Linux, I can start to be more intelligent and say, hang on a minute, server 1 has just sent you 20 PowerPoint documents, and server 2 also has 10 of those 20 documents on it, and server 3 and so on. So what we do with global dedupe is that once that block has been backed up from one machine, we're comparing the data structures coming in across all the other nodes, and if that block is duplicated on any of the other nodes, it doesn't get backed up because we've already taken that block from one of the nodes. And global dedupe is the most effective way to deduplicate the data, because you're globally referencing the data coming in from multiple sources, and that will give you the highest data deduplication ratios overall. But also, because we're doing it at the software level, we're writing significantly less data to the backup server, so your backups will run very quickly over the network because it's only pulling the unique data. And at the back end, you're still using that general storage, which is low cost, you know, nearline SAS or even NAS in smaller environments can be used as well. So the overall cost of the solution is significantly lower, and you're getting the benefit of global source-side dedupe, which is really going to reduce the amount of data that you're backing up overall. Now, when you look at ArcServe UDP, UDP works in a similar way. We use source-side global dedupe. So if I'm backing up physical or virtual servers or workstations, the recovery point server, or RPS as it's seen in this diagram, is really where all the intelligence happens. This is our dedupe global repository, and it's comparing data structures coming in from all the different sources that are being backed up across your network and in your environment. But the dedupe doesn't stop there. With UDP, as well as doing that source-side global dedupe and really significantly lowering how much data we're backing up, and we can use low-cost storage to hold that backups data. We've also got dedupe at different levels as well. We dedupe around the replication. So before we transmit recovery points between nodes, we're comparing data structures at both locations and actually calculating what's unique. So if logically I'm going to send 100 gigabytes of data off-site, because that's what I've just backed up before dedupe, I will analyze those blocks and only maybe send 2 or 3% of that data across the wide area network to my DR location. And it could be a remote site data coming in as well, and that's all been globally deduped and compared to the backups that are running in your primary site. So if there are common blocks between the two, we won't back them up again. And then when the data gets to the DR location, we've got really clever technology to do things like virtual provisioning, where we can actually spin up VMs from your backup recovery points. And it really provides the scalability that you would need. Without dedupe, any backup solution would be limited. But with us, dedupe and global dedupe and dedupe around the replication are really the key enablers to back up a lot of data over quite a long period of time and significantly reduce and compress that data down. Now, when you measure dedupe, this is kind of, I suppose, how we measure it, because again, you will speak to backup vendors and they say, oh, we get 30-to-1 compression on our backup data, and that sounds fantastic. You know, for every 1 terabyte, you know, I could back up 30 terabytes and only store 1 terabyte on disk. Now, a lot of these ratios that backup or dedupe vendors and backup vendors claim is based on the premise that I do a full backup every day. So I'm comparing the source size that I've backed it up 30 times. So if I've got 20 terabytes, the 30-to-1 calculation is basically 30 times 20, which is 600 terabytes. And then they'll say to 1. So if they've got 600, 30-to-1, they will divide that up, and you'll end up with, sort of 20 terabytes on disk, and you think I've backed up 6 terabytes, I've got 20 terabytes on disk. That's actually quite good. That's given me a pretty compressive rate. But most backup technologies now have moved on beyond there because, for example, with UDP, we do incremental forever. So we're only capturing the change blocks. And that's really important. You don't want to be doing full backups every day because the time it would take you to run that would be ridiculous. So if you're capturing the change blocks, so if you take the top model here, this is, for example, a VMware or Hyper-V backup. And the first backup is 1 terabyte, it's 1,000 gig, thereabouts. Now, the first day you back it up, it will take a full snapshot because we need to get a baseline of the blocks. The second backup you do will basically be the changes that have happened since the first backups. In this case, it's 50 gigabytes. And the third backup that's been taken is, 1,100 gigabytes, which is basically another 100 gigabytes on top of the base image. Now, in terms of total recoverable size, that's 3,150 gigabytes, because I could do a full system recovery of that system or that data from any of those recovery points taken. So logically, we backed up, we're protecting 3,150 gigabytes. Physically, we're backed up 1,100 gigabytes because they're the changes plus the base data. Now, when you start to introduce dedupe to that process, you'll notice that the first backup is reduced from 1 terabyte down to 400 gigabytes because we're deduping the blocks, and any duplicate block is taken out, and we're creating those hash keys that are going into the hash database and they're being indexed. So we get a significant data reduction straight away. But then if you look at the change block daily backups, we're also deduplicating those as well. So that 50 gigabyte block change has been taken down to 20 gigabytes. So again, you're getting an immediate reduction. And the same for the third backup, that another 50 gigabyte of change has been taken. So in total with Dedupe on its own, we've reduced that backup down from 1100 gigabytes down to 440 gigabytes by just adding Dedupe. And then if you compress the data, and again, this is looking at compression on its own, it's basically reducing the data again. So compression on top of the Dedupe, we're taking it from 400 gigabytes down to 280 gigabytes. Also, the 20 gigabyte Dedupe size of that daily backup has been reduced down to 14 gigabytes. And you can see then that with compression and Dedupe, we've turned 1100 gigabytes down into 308 gigabytes. So you've got a total data reduction from the logical size in terms of source protected down to the compressed and Dedupe size. It's a 90% data reduction overall. So this is how we measure Dedupe. It's quite simple. How much have you protected at the front end versus what's on disk after compression and Dedupe? And that's really the true best way to measure the effectiveness of your Dedupe, is how much are you protecting versus how much is stored on disk. And we show you that very clearly in our recovery point server view through our console. So I'll give you some examples now, and these are UK customers. I'm going to talk about one customer that we have in the UK, and this customer is in the south of England. They back up, well, it says in this slide here, just under 50 terabytes. Sorry, there's a bit of animation on this slide. I need to take it out. And basically, they've got 3.18 terabytes on disk. Now, this customer now backs up over 250 terabytes, and they've got something like just under 15 terabytes of data on disk. So this customer also wrote an article on Spiceworks, and they're getting, a 93% data reduction overall, 90% Dedupe rate plus an additional 36% compression, which gives them an overall Dedupe rate. And they actually wrote an article on Spiceworks showing that information. Now, there is a screenshot at the bottom there, sorry, for the Open University. They're backing up over 512 terabytes of production data in terms of what they're protecting at the front end. And they're actually holding just under 14 terabytes of backup data on disk. So they're getting a 97% data reduction overall, 96% Dedupe and 29% compression. So again, these are proven stats. We've got success stories with these customers, and you can actually get this information publicly from our website. So we're not making anything up here. Now, these are some more customers. We actually run a Twitter competition last month where we were actually asking customers, UDP customers, to send in their Dedupe rates just to get a feel of what our customers are getting in the real world. And a lot of customers sent in screenshots showing their Dedupe ratios. So we have one customer at the top there. They've got different data repositories, data stores. You can see there that one of them is 467 terabytes. On disk, they've got 30 terabytes in that data store, 94% data reduction overall. Another one that's 143 terabytes there, then they're backing up just over 8 terabytes on disk. So overall, that's pretty good. We had another customer. We've got actually one customer that is a major global provider of payment processing and billing services. We can't name their name for legal reasons because they're not a reference account at the moment. But they're backing up over 700 terabytes of data. And they've got 23 terabytes of data in their data store. I think it's about a 97% data reduction. So we're not saying every customer gets, these rates, but what we are seeing a trend is, it's not untypical now to see a customer anything from 85, 87, 88% data reduction all the way through to the the mid-90s in terms of data reduction. So we know, hand on heart, that our dedupe technology is providing very effective dedupe ratios overall for most of our customers, and that makes us quite proud that the technology that we developed and the logic in that technology is a good design, and it's scalable, and it's working really well. Now, in terms of setting up the dedupe, this is the process of setting up a dedupe data store. You can see it's quite straightforward. When you build a data store, which is a storage pool in UDP, you just tick the option that you want to use data deduplication to deduplicate the data, and then there's a number of directory structures that we create to hold the data indexes, and the hash database. The hash destination is key. What we do recommend, there's two ways you can run the hash destination. You can run it in RAM mode, where if the server's got a lot of RAM on it, you know, say you've got a server that's got 128 gig of RAM, you can just basically allocate along that hash memory allocation scale. You can just slide that along and maybe allocate 32 or 64 gigabytes of RAM, depends on how much data you're protecting. If the server doesn't have a lot of RAM, we recommend that using an SSD card on the server, a card that's kind of designed for read access, read intensive lookups, you know. So you do get SSDs that have got optimized for write performance or optimized for read performance. We tend to recommend the ones optimized for read performance. And you'll notice that the hash destination there is on the H drive, because that's on a faster disk. And then you can put the volumes and the indexes on different drives, as you can see. And you can also set the dedupe block size there, and you can see this example set to 4K, which is going to give you very high dedupe ratios. We've also got a planning tool which helps our customers calculate what the potential benefits would be with their own data. Now, we do have estimator tools when we're working out customers if they're looking, you know, to implement UDP via a software or an appliance. We can basically plug in your numbers. We can say, okay, you've got 50 terabytes of data, you're backing up 100 servers, you want to hold 31 recovery points on disk, which could be a combination of daily, weekly, monthlies. We can put in the estimated compression and data deduplication rates that we get across the industry on average for most of our customers. But if you want to take that accuracy to the next level, we have an analyzer tool that you can actually run at your site against a sample of your servers. So we wouldn't say run it across 100 servers. We would maybe pick your Exchange server, your Oracle server, your SQL server, your SharePoint environment, a couple of file servers, X number of VMs, a couple of physical servers, just to kind of give us a representation of your environment. And we would run this tool over a number of days. And that would actually help us to calculate what the actual compression and dedupe ratios we would get with your data in your environment. And then what we can do is we can plug these figures, the outputs of these tests, into our estimator tool to make the estimation even more accurate, to give you a very accurate sizing of what type of server and how much storage and how much CPU memory, or if you were buying an appliance, what the correct model of appliance would be to suit your environment. Now, we believe that these are the sort of key things that you have to look at and have to consider when you're buying a backup solution with dedupe technology. Okay, first of all, we believe that inline dedupe has to be a must. Post-dedupe works okay in the sense that you will eventually get the data reductions. But the downside with post-dedupe is that you need to have a lot of storage available to hold that initial full backup and every subsequent backup before it's crunched down. So this is why when you're speaking to an appliance vendor, if you're looking at solutions like Unitrends or Barracuda or Veeam, ask these questions, because depending on what answers you get will help you qualify if you're going to get the best dedupe rates going forward. So inline really is a must for us. The benefits of inline are obvious. You use significantly less storage. We don't need this big landing area to hold the backups. Also, a small block size, you know, as we've seen by reducing the block size, you get significant dedupe ratios. You don't want to be setting up really large block sizes or doing file level dedupe. File level dedupe works well, for example, on email servers where you're sending a PowerPoint out to 50 email recipients. The email server uses single instance storage, and it will hold one copy of that file and reference it to the 50 people it's been sent. In an email archiving or an email solution, kind of doing file level dedupe kind of makes sense. But in the real world of backing up lots and lots of terabytes of data, you want to turn it into smaller block sizes. Global dedupe, it's a no-brainer. If I'm backing up 100 servers, I don't want to be backing up 100 times, 100 copies of Windows 2012 operating system, 100 copies of the same file that's on 50 of those servers or whatever. You want to be able to globally dedupe the data. Source side dedupe is another key, importance. If you dedupe at source, it means it will only send the unique data. It won't send the bulk of the data. There are a lot of solutions on the market that will send the incremental backup sizes across the network, but that could be the difference between sending 100 gigabytes versus 5 gigabytes, or 20 terabytes versus 2 terabytes, and that backup time is going to be significantly lowered by only sending the unique data from the source. Auto WAN optimization, again, this is really important, because if part of your strategy is to replicate recovery points off-site for DR, or you want to replicate to the cloud, a lot of cloud solutions now will have a costing model based on how much data you upload and how much data you download. You also, the chances are if you're using a cloud, you're sending data over your internet connection from your business to the cloud. And the last thing you want is something that's going to hog all that bandwidth because it's taken hours to upload and pull data back from the cloud. So WAN optimization, or another way to term that is dedupe around the replication, is critically important, okay? Now, this is just some, I suppose, competitive analysis that we've observed by some of our competitors. And you'll notice that I'm going to talk through each of those here today. So if you look at Veeam, Veeam's a very popular backup and recovery solution. Many customers in a VMware or a Hyper-V environment are looking to use Veeam, or they use Veeam. Now, one of the big drawbacks Veeam has is the fact that their dedupe repository isn't global. So if you've got 3 or 4 different backup plans, and there could be logical reasons for that, you may want to create a plan that you're doing a different backup schedule to other servers. You may have a platinum plan that, as well as doing daily, weekly, monthly backups, you want to take snapshots every hour, every 30 minutes, because these are your tier 1 servers. And the reason why you have them in a separate plan is because some of your servers could be on a standard policy, which are just daily backups. So you don't want to back up all your standard servers every hour, because there's no need to do that. So you would create different plans for different logical groups of machines, for example. Now with Veeam, I have to have a backup destination or data store or storage pool for each plan. So if I've got a Veeam backup server and I've got 4 plans to split different groups of servers up in my organization, I have to create 4 backup pools for each plan to back up to. We can't share the same pool across different backup jobs. So the per job dedupe approach isn't that efficient, and they also use quite a large block size. And Veeam will tell you that the reason why they use a large block size is they get faster restore performance. But in reality, if you read a lot of the Veeam forums, they actually push hardware dedupe appliances to complement their technology, because they will never admit it officially, but their dedupe technology isn't that good. And as a result of that, they're often saying to customers, go and buy a data domain box if you're in a very large environment and you want to get true global dedupe on our backup sets and to really drive higher dedupe ratios. So, and that's why you can see that second arrow, it says rededupe, because they're pushing you to dedupe the data again using a more effective dedupe solution at the back end. If you look at a lot of the appliances on the market, we're using an example of Unitrends here. Now, up until very recently, Unitrends only did post-dedupe, which meant that you needed to buy quite a large appliance to hold your backup data. If you had 50 terabytes of data, Unitrends would sell you an appliance that's got 100 terabytes of disk in it. And the reason why they needed to do that is because they don't do inline dedupe. So they would need the amount of disk to basically hold a full backup on disk, plus a working area to crunch that data down after the backup completes. So eventually that 100 terabytes or 50 terabytes, sorry, may be turned into 10 terabytes or 8 terabytes. But initially they need to hold the full area, the full size of the backup on disk. Now they have introduced a slight improvement where they do partial inline dedupe to slightly improve, but fundamentally it's still a post-dedupe process. They've just done it in a way now that they've reduced its working space so they can try and limit the amount of disk they need. But fundamentally, for Unitrends to really improve it, they would have to completely redesign their dedupe engine to be more effective. Now with ArcServe UDP, we use 100% inline dedupe, 100% source-side dedupe, and true global data deduplication. So unlike Veeam, we get very impressive dedupe ratios directly from the software. We actually discourage customers to use dedupe appliances. We actually work much better with low-cost storage, like a nearline SAS direct attached disk array, or even NAS in smaller environments, and use our dedupe technology in our software. So our dedupe is really efficient and very effective. Now, if you start to look at, we've got a kind of comparison chart here, which gives you a quick look up of what we're doing. So when you compare our products to others, 100% inline dedupe. Again, if you look at Veeam, Veeam process dedupe per backup job, so it's not true. It is inline, but it's not a very effective method. So we kind of give it half a point there. And Unitrends, again, Unitrends performs post-process deduplication for application backup. So it's not 100% inline. 100% source side, again, UDP provides that. There is a limited capability with Unitrends to support source side dedupe on VMware jobs only. But if you've got physical or Hyper-V environments, you can't do source side dedupe. Global dedupe, again, Veeam don't provide that because they need a separate backup repository for each plan. We provide that. Unitrends, again, have performed global dedupe across disparate storage devices, but it's not an effective way like we do it. We've also got no dedupe appliance required. Again, both ourselves, Unitrends, we use our own technology. We don't have to use anything else. Veeam often require costly dedupe appliances to get the best dedupe ratios overall. And again, the built-in WAN optimization, the dedupe around the replication, we do it in the most effective way to send data off-site in a very efficient way. Again, Veeam requires a proxy server for WAN optimization, which is another component, which is a chargeable component in their environment. So ArcServe UDP versus no dedupe backup, you can see here that if you were using a solution that didn't have dedupe, a full backup in this example would be 217 gigabytes. You might get a small data reduction because of compression. The second full backup, 206, so again, you would be backing up a lot of data, 434 gigabytes from, a 534 gigabyte backup. So you're getting a small reduction there. Now with dedupe and compression, we will get a 56% data reduction initially on the full backup. And then as we start to back up the changes, we get very high dedupe ratios. And this is really where, just even after 2 backups, you would probably get something like a 76% plus data reduction. After 10 backups, it's probably in the high 90s overall. So again, just to re-emphasize the point, if you are looking at a backup solution, make sure it's inline, 100% inline. Make sure it supports source-side dedupe. And global dedupe is really important as well. Okay. So just a bit of information on Arcserve. We are a global company. We were part of CA Technologies up until about August, September 2014. We are now a privately owned, independent data protection company, and it's allowed us to develop our technology into different areas. Actually, in the last 12 months, we've won significant awards in the industry. In VMware Barcelona, which is VMworld Europe, we won Best of Show and Best Virtualization in DR project for a project that we did with the Open University in Milton Keynes called MK Smart. In VMworld in America, we also won the Gold Award for Best Disaster Recovery and Backup for Virtualized Environments. We've also been given very positive and high scores from PC Pro magazine. CRN Channel Chief Awards was given to Mike Crest, our CEO. And we're getting recognition across the global industry now. In terms of the company, we are a large company in the fact that we've got over 45,000 customers. We have over 7,500 transacting partners. All the Arcserve technology is sold through our partner business. We don't sell direct. And we have global offices and HQs in different parts of the world. Our EMEA HQ is in Barcelona, in Spain, and we've got offices, our head offices in Minneapolis in the US, and we've got offices in other parts of the world as well. So just a bit more about who we are. So that's it really. I'm going to open this up for questions now. If you do have any questions that you want to ask, please use the question panel, and we'll attempt to answer any of those questions that you have. We will be sending out a copy of these slides, and this session is also recorded, so we will try and get the recording link sent out to you if you have any colleagues that would be interested in listening to this as well. So thank you very much for your time. I'm going to stop speaking now, but if you do have any questions that you want to raise, I will stay online for the next 10 minutes to answer questions that are raised on the questions panel. And if you look in your GoToWebinar software panel there, you'll see a section called questions that you can open up there. Okay, I hope you've enjoyed this morning's session. My name is Charlie Smith, and I look forward to speaking to you soon. Thank you very much. Thank you. Bye-bye.